This is Module 1, Lesson 1.1, Functions and Continuity. The standard is MA.912.F.1.7. Compare key features of two or more functions, each represented algebraically, graphically, in tables or written descriptions. Some key reminders from previous courses is that the domain is the set of x values. Evaluated by a function, the range is the set of y values. That is a result of the evaluation. If each element of a function in the range is paired with exactly one element in the domain, then it is known as one-to-one. In example 1, it wants us to identify the domains and ranges. So identify the domain and range of the function. The graph on the left is showing the domain. Notice that the arrows is gold-faced because it's representing the x values. So because there are no restrictions on the x values, the domain is going to be all real numbers. When we look at the range represents the y value. So those are your up and down motion. Notice that the parabola they're showing in this instance is opening down, but the y value stopped at the value of 0. So because the maximum value of y is 0, the range is going to be y less than or equal to 0. In our check value, it wants us to look at the graph on the right, and it says, consider the graph of f of x shown. So this says they're wanting to find the domain of the function. So I'm looking at remember again, domain is your y values, your x values, domain is your x's going left to right. And these arrows on the graph, they're going to keep extending left and right. Because they're going left and right, we are also going to be all real numbers. When we look at the range, again, remember the range is your up and down. Range is your up and down motion of the y values. Because the highest values is right here at y equal to 3, but opening down, because the graph arrows are opening down, you have to be less than or equal to the value of 3. When we head to discrete and continuous functions, you can have functions that are discrete, continuous, or neither. What that means is, what that means is that based on the type that you see, it can model real-world situations determined by its constraints. So remember, a constraint is a condition that solution must satisfy. We have continuous functions. We have a continuous function, which is a graphed line with a graph line or unbroken curve, which means, like, think of a parabola. Then we have a discontinuous function, which means there's a break in your graph. After discontinuous function, there we have what we call discrete functions. It's where the points are not connected. So then again, discontinuous, there is breaks in the graph. Discrete is there's no points connected. Neither means that some points are connected, but not continuous everywhere. In example 4, they want us to determine the continuity from the graphs. So we're either going to determine if the graph of the function is discrete, continuous, or neither discrete nor continuous. When we look at the example A, f of x, we notice that the graph is going from left to right, increasing. So when we look at this, we know that it is a continuous function because it is moving from left to right. So because it is being continuous, we know that the domain is all real numbers and its range is also all real numbers. When we look at example B, g of x equation, we notice that there's a break in our graph. There is an open circle. We can see the open circle right here. Because there's a break in the graph, this means it is neither because of that continuous. It is continuous for parts of it, but not all of it. There's a break in your graph. Now, because there's a break in our graph, we can say that the domain is going to be all values of x except x equal to 2. The same thing with the range. Because of that break, the range is going to be all values of y except y equal to 1. When we look at C, h of x, there's nothing connected. We have nothing connected. Because there's nothing connected, it means it is called discrete. When we go to assign the domain, you actually have to put all the values that we see. So our domain is going to be the set of -3, -2, -1, 1, 3, 4. And then the range is going to be the values that the y values are from those ordered points. -3, -2, 1, 2, 3, and 4. Set builder notation and interval notation. So something to remember back from your Algebra 1 days is that set builder, the algebraic notation, is going to be expressed as just an algebra problem. It's going to be expressed just as an algebra problem. Set builder notation, you're gonna take the algebra solution and then add braces on the end of them, which means you're just gonna put the little backwards faces. When we go to interval notation, that is just your boundaries. The interval notation are gonna be your boundaries. So like, if I'm gonna use parentheses, means that the numerical value is not included. If I use a bracket, means you're including the value. So for an example, if I use parentheses -infinity, 2 with a parentheses, it means all the values between 2 all the way to -infinity would work, excluding the value of 2. If I had changed it and said from -infinity, 2 with a bracket, then I'm including the value of 2. That is the difference between the two of them. So let's look at example 6. It's talking about set builder notation. It wants us to write the domain and range for the given graph. So when we look for, remember, domain are your x values. Domains are our x values. So in this instance, the domain is going to be all real numbers. So you would write it as x if and only if, that's what that represents, that line. X is all reals. And we use an R, capital R, to represent reals. For the purpose of set builder notation, set builder and interval notation, for an interval notation, because we're representing from -infinity to +infinity, then it's going to be the +infinity symbol. When we go to the range value, again, the range are your y values. The range are the y values. So when I look at my problem, the lowest point right here is at -6, but I keep increasing. So the least value for y is going to be at -6. The range is going to be all real numbers greater than or equal to -6. So y if and only if y is greater than or equal to -6 is what we're going to write it as. Let's look at our check value. So in our check, it says state the domain and range of each function in set builder and interval notation. So we're going to start with first our domain. So our domain, remember, it wants us both in set builder and interval notation. So the domain is going to be, in set builder notation, we're going to go from braces x, if and only if x is all real numbers, because remember, domain means left to right. In our range for this problem, remember, it's the y values. So the highest peak on the y's is here at 3. So x, or actually not x, y in this instance. Use our y value. If and only if y is less than or equal to 3. Close the brackets. This is set up in set builder, but now they want interval notation. Interval notation, remember, that is just the parentheses part. So our domain, we're going to be -infinity to +infinity because we are all real values. Our range, since 3 happens to be the highest point and there's no break, you're going to go from -infinity to positive 3 with a bracket. Now when we go to the other graph, notice that the graph is going from left to right. So if I were to tilt my graph to run it parallel to the x-axis, our domain is going to be x, where x is all reals. Our range in this instance, again, if I were to run it parallel, lay it on the y-axis, your y values are also going to be y, where y is all reals in this instance. In interval notation, then the domain is going to be from negative infinity to positive infinity, and the range is also negative infinity to positive infinity. In example 7, they want us to do set builder and interval notations for discontinuous intervals, so where there's breaks. So they want us to write the domain and range of a function in set builder and interval notation. When we look at our domain for the first graph, notice that the domain on the first graph, there is a break here at -1, and then we see it again picking up at x equal to 0. So the domain of all real numbers are going to be less than -1, or, because notice that it's a solid dot at when x is 0, greater than or equal to your spacing might be a little bit more than I am, to 0. So when I look at interval notation, set builder says x if and only if x is less than negative. I used only a less than symbol. I did not put a line underneath it because it's an open circle, or x greater than or equal to 0 because it is a solid dot. Now when we go to interval notation, again, negative infinity to -1, I'm using a parentheses for the -1 because I'm not including it. The U means union. Then we used a bracket for 0, going to infinity, and I'm also using a parentheses because anytime infinity symbols are used, you must use a parentheses only. You cannot use a bracket. When we go to the range value, when we look at the range, notice that the y value, the range are the y values. So here's -1, and here is +2. So the range is all real numbers less than -1, because again it's going down, or notice that the y value is a solid dot, so greater than or equal to +2. So for our set builder, y if and only if y is less than -1, I did not include the value line, or greater than equal to put a brace at the end. Interval notation, negative infinity to -1 with a parentheses, because we're not including the -1 value. So on this one, they want us to do a check. They want us to state the domain and range of the graph in set builder and interval notation. So on this one, when we look at domain, remember domain are your x's. Domain are your x's. So I have -1 here, +1 here. So I'm marking my pieces as to what I'm looking for. Our domain, x if and only if x is less than -1, because again it's open at -1, or x is greater than equal to +1 because it is solid dot there. When we go to the range value in set builder, the y values, notice that the y values are going up and down. There's basically it's not stopping, because here we include the value of 1, we include the value of 0, we include -1, and we keep going. So our range is going to be y, where y is all reals. When we go to set builder notation, interval notation now on the other hand, apply what we just did. So it says x is less than or equal to -1, so I'm going to go from negative infinity to -1, parentheses, union. bracket 1 to infinity. Close the parentheses. Now for the range value, again, the range, we said it was all reals. So from negative infinity to positive infinity.